How will the climate of the Earth be in 2050 according to the theory about the greenhouse effect and the theory about cosmic rays? The theory about cosmic rays and solar activity as a crucial factor for the formation of clouds and temperature on Earth is a theory developed by the Danish scientist Henrik Svensmark. Cosmic rays are small particles coming from space. They are made of carbon, sulfur, and dust and are called aerosols. Cosmic rays are naturally found in space after a stellar formation, explosion, or evolution. Around the Sun exists a protecting shield named the heliosphere. The magnetic field is to be found in the heliosphere. The strength of the magnetic field works as a shield against the solar activity, and it is depending on the solar activity. A high solar activity entails fewer cosmic rays. It has long been a known fact that cosmic rays on Earth are dependent on the solar activity. What is pioneering in the theory developed by Henrik Svensmark is the relation between the cosmic rays hitting the Earth and the formation of the low-lying clouds, which has a great impact on temperature and the climate on Earth. Water vapor can condense and create low-lying clouds, but this requires particles that the water vapor can condense on. Henrik Svensmark believes that aerosols from cosmic rays are important particles in the formation of low-lying clouds. The low-lying clouds have a cooling effect on Earth because the water vapor inside of the clouds reflect the solar rays. Henrik Svensmark understood some relations between the amount of cosmic rays which hits the Earth and the amount of low-lying clouds. He created a prediction stating that two factors are depending on one another. He wanted to prove his prediction in an experiment called the sky experiment. The observations of the experiment proved a relation between changes of cosmic rays and changes in the properties of the formation of low-lying clouds. The term the greenhouse effect describes the atmosphere's ability to absorb more of the sun's rays than it emits back out. The sun emits short-waved ultraviolet rays which passes through the Earth's atmosphere down to Earth, where some of the rays are absorbed while others are reflected back out into space. The rays absorbed by Earth will be re-emitted again in the form of long-wave thermal radiation. At this point, the greenhouse gases play a major role as they absorb this radiation. Because the greenhouse gases are located further up in the atmosphere, the radiation emitted from them is less than it would have been if emitted directly from Earth. By doing so, some of the energy originating from the sun, atmosphere, etc. will contribute to the heating of the atmosphere. This model shows observations from the sky experiment as a function of time. The relation between the amount of clouds and the amount of cosmic rays which hits the sun is very obvious. The beryllium-10 isotope, which is represented by the red line on the graph, is an isotope created in the atmosphere. It settles on the ice in Greenland and Antarctica when cosmic rays hit the Earth. It is therefore possible to measure the amount of cosmic rays through time in ice cores. When the rain falls on Greenland and becomes ice, it is possible to measure the concentrations of oxygen 18 in the precipitation, and by calculating the difference between these data and the standard for the concentration of the oxygen 18 isotope in seawater, you can determine the temperature changes throughout time. A small difference between the concentrations means a warm climate and vice versa. Ice cores are therefore very useful to investigate the climate changes on Earth throughout time. It can be seen on the graph that the temperature changes relatively synchronized with the number of sunspots throughout time, which means that a high solar activity equals a small number of cosmic rays hitting the Earth, which will mean a decrease of the cloud cover, and as a result of that, the climate on Earth is heated. During an excursion to the Institute of H.C. Ørsted, we conducted a scientific experiment with the purpose of measuring several greenhouse gases' abilities to absorb both long-wave and short-wave radiation. The experiment was carried out by sending firstly long-wave radiation and secondly short-wave through a tube containing the different gases, by which it is possible to compare their absorption abilities. Our basis hypothesis was that the greenhouse gases contributed to the heating in the atmosphere. Based on the hypothesis, we predicted that the greenhouse gases in the tube would in fact absorb radiation. We tested our hypothesis in the experiment, and based on the result we were able to confirm our basis hypothesis. With this experiment, we can conclude that water vapor has the highest absorption, and it is made clear that greenhouse gases are able to absorb heat radiation. This must mean that more greenhouse gases will increase the total absorption of heat radiations, which will cause further heating. Further heating will lead to different feedback mechanisms such as an increased vaporization of water. Like with all climate models, the theory of the greenhouse effect and the theory of cosmic rays too have limitations. The main problem being that it is not possible to set up models of the Earth and atmosphere which take into consideration all variables. By not including all variables, there's a risk of drawing conclusions between two factors that, in reality, perhaps don't depend on each other. The problem becomes clear as the two different theories of the climatic changes links the rays and temperature in the atmosphere to two completely different factors. On the basis of information about the ocean, we have calculated the expected sea level rise according to the predictions by the two theories. To calculate the sea level rise, we started out by calculating the volume of the upper 700 meters of the ocean. The next step is to calculate how much this amount of water will expand due to thermal expansion. We then go on to calculate how much this will cause the sea level to rise. Respectively, 15 and 4.5 centimeters are added to the results in order to take into account the amount of ice that will have melted in 2050. Based on the greenhouse effect, the temperature is estimated to increase with 2 degrees Celsius, while the estimation based on the cosmic ray theory predict a temperature increase of only 0.6 degrees. Our final results show that according to the theory of the greenhouse effect, the sea level will rise with 39.3 centimeters, and according to the theory of cosmic rays, with 11.8 centimeters. Our estimated increase in the sea level will not create important changes in neither Denmark nor India. But if the development of the climate changes continues, it will create a very critical situation in low-lying areas in India as well as in Denmark.